All right, let's do one of these really quick to remember how to do a long division problem. We've used calculators a lot. We want to make sure that we remember how to long divide so that we can long divide in polynomial style. So what's the first question we ask ourselves when we're dividing 276 by 12? Good. Same process with polynomial division. So we say 12 goes into 27 twice. And then what's the next thing that we do? Multiply. And then we multiply 12 by 2. All right, so we get 24. And then what do we do? Yep. So we change the sign and we get 36. And we say how many times does 12 go into 36, right? And we say 3. So we multiply and then we change the sign and subtract. And this had a remainder of 0, right? Okay, so we didn't have to write anything. What if it didn't have a remainder of 0? Let's say this was a remainder of 1, if it was 277 instead. We could say R1, right? Or we could say N1/12, right? Anybody remember that? Okay, it's been a long time, maybe 4th grade since you did this. In this case, it's 0/12, right? So that's the process that we're going to use with long division with polynomials. Okay, so let's look at that. Long division of polynomials is especially used when you have a non-linear divisor. So in this case, we could use something called synthetic division, but we'll start off basic. We have 2x cubed minus 5x squared plus x minus 8, and we're dividing it by x minus 3. So if you remember synthetic division works with this one, but we'll long divide it out. So we start off by, first of all, checking. Do we have all the powers of x here? Third, second, first, 0, yes. So we don't have to hold any places. We don't need any spots to be held onto. So we're going to say 2x cubed minus 5x squared plus x minus 8. And we're dividing all of that by x minus 3. So just like before, when we said how many times does 12 go into 27, this time we're saying how many times does x go into 2x cubed? So what would we have to multiply x by to get 2x cubed? 2x squared. Okay, now we multiply everybody by 2x squared. And by design, this one's going to go away, but a negative 3 times a positive 2x squared is negative 6x squared. Now we go through and we change the signs because we're subtracting. So we change the signs of both. The 2x cubes go away. Bless you. And a positive 6x squared with a negative 5x squared gets us x squared. Bring down your x. Now we ask ourselves, how many times does x go into x squared? X. So we have to multiply x by x to get x squared. Multiply x by x and negative 3 by x. We want to subtract. That means change the signs of everybody. And we get 4x. Bring down the 8. X times what gets me 4x? 4. Multiply. Watch your signs always, and change the sign. What's my remainder? So how do we write that as a fraction? 4 over the, yep. Because we had a remainder, we know x minus 3 was not a factor. 3 is not a 0, right? But we end up with the polynomial function. Yes, sir. Good question. So why did we change the signs back here? Same idea here, but we want to be careful to change all the signs because it's like subtracting this guy off. And so it would be like saying, I'm going to take a minus of this 2x cubed minus 6x squared. Well, we have to distribute that negative 1 to both. Okay, so it's very, very important to make sure you change the signs of both, not just the leading coefficient or the leading one. Okay. Great questions. Other questions about this slide? Okay. Next one. This is one that you can't use synthetic division, which we'll talk about in a minute, remind you of, because it doesn't have a linear factor like x minus 3. Okay, now we have a x squared plus a 2x minus 3. So first step when you're writing these down is always to check, do we have any missing powers of x that we have to hold a place for? Nope. Morning. So same process, same question that you have to ask yourself. What do I have to multiply x squared by to get 2x to the 4th? 2x squared. So I multiply everybody by 2x squared. Bless you. Lots of sneezing going on. And then I have to remember that we're going to subtract all of that. So I have to distribute that minus sign to everyone. So I'm going to change the sign of every single term. And nicely, the 2x to the 4ths go away by design. And the 4x cubes went away. So now I'm left with just x squared. Bring down your 3x. Bring down your minus 2. Now, what does x squared have to be multiplied by to get x squared? 1. So we're going to put a positive 1 here. Multiply everybody by 1. Then distribute that minus sign to everyone. Not just the first term. 3x squared minus 2x is a negative 2 plus 3. So that's the remainder. And then we write x squared plus 2x minus 3. Questions about this slide? Remembering? Good question. Sometimes we can factor things out. So this would be, I love that thought. Let's see if this would factor. X plus 3, right? And x minus 1. Okay. Now, if it was exactly x plus 1 and x minus 1, they'd cancel, wouldn't they? But that was a very good question. Okay. Does everyone see where she was going with that? Maybe we could get rid of that x minus 1, or the x plus 1, actually. All right. Next slide. One more long division. Make sure you remember how to do it. We're dividing x cubed minus 1 by x minus 1. Are we missing any terms now? So we might want to hold their place. So we've got an x cubed, no x squareds, no x's, and a minus 1. And we're dividing that by x minus 1. So what do I have to multiply x by to get x cubed? X squared. So I will get an x cubed, but I'll get a negative x squared. I want to subtract, so I have to change the signs of both. Distribute that negative through to both, and I will get a positive x squared. And I have no x's with it, but if I want to bring that down to help me keep things lined up, that's great. Now what do I have to multiply x by to get x squared? X. And that'll be a negative 1x. Change my signs. So I can subtract, and we get an x. What do I have to multiply x by to get x? 1. And so I get x minus 1. If I change my signs, finally I get a remainder of 0. Okay, so I don't have to write that plus fraction at the end. Which means that x minus 1 is a factor of x cubed minus 1. And the remaining polynomial that we have left is x squared plus x plus 1. Questions you have on this slide? Everybody feels good about long division with polynomials? Okay. So don't write this down. You can refer to it in your book. Okay, just think about it and think about what it's saying. The division algorithm says that for all polynomials f of x and d of x, such that the degree of d is less than or equal to the degree of f, and that polynomial function d of x is not equal to 0, there exists the unique polynomials a and r of x, such that our original function is equal to our d of x times our q of x plus our r of x, where r of x equals 0 or the degree of r is less than the degree of d. Okay, that's how it's going to, our book is going to tell you that if we take f of x and we divide it by another polynomial, we're going to get a result, right? And maybe a remainder. And if that remainder is 0, great, it won't show up. But if it's not a remainder of 0, that remainder has to be a polynomial of lesser degree, and we write it over the original divisor. Okay? Formal presentation. We just did it over and over. Make sense? Probably not, because it's very formal. And that's okay. That's how our book is going to formally present that. Synthetic division now is only going to work when, like I said, we have a linear divisor. It has to be x minus k or x plus some number. X has to be to the first power. So this time we're dividing 3x cubed minus x squared plus 2x minus 3 by x minus 2. And we're going to strip off all of those variables to save ourselves a lot of writing and a lot of space on our notebook and a lot of paper. So first we ask ourselves, are there any missing powers of x? No, so we don't have to hold any places. So all we do is strip the coefficients off. We say 3, negative 1, 2, negative 3. And we put a little box over here. When we're given the factor, we always put what would be the 0 in this spot. So if this is x minus 2, what goes here? Positive 2. And then we draw a little line down here and give ourselves some space. So the 3 comes down unmolested. Nobody does anything to it. But then we have to take 2 times 3 and get 6. And now, because we've changed this sign already, we don't have to worry about subtraction anymore. So we're just going to add. Okay, before we had this, right? Now we've changed the sign to make it kind of a subtraction problem every time. So now we add. Negative 1 and 6 is, 2 times 5 is, 2 plus 10 is, 2 times 12 is, 24 and a negative 3 is. That guy is your remainder. So this is no longer an x cubed. It's been depressed by 1. So this is now a 3x squared, a 5x, a 12, and the remainder of 21 over what we divided by. And that's a whole lot less writing. Remember that? What questions do we have on this slide? Okay, I'll let you practice the next one. So if a polynomial, this is the remainder theorem, but if a polynomial f of x is divided by x minus k, the remainder of f is the same thing as what f of k was. So in this case, if I plug in, this is being divided by x plus 1, right? So if I wanted to know what f of negative 1 was, I could plug negative 1 into every one of those spots and evaluate, or I can synthetically divide. Okay? So first look for any missing powers of x and write down your leading coefficients, or all of your coefficients, not your leading coefficient only. And what goes in your box? Negative 1. Because if we're testing if x plus 1 is a factor, we want negative 1 as the root, as a 0. See how much quicker that is? We drop down the 2. Negative 1 times 2. Add. Negative 1 times negative 10. Add. Negative 1 times 7. Add. Now let's verify. If we were finding f of negative 1, we would take negative 1 and plug it in everywhere we see an x. So we would have 2 times negative 1 cubed minus 8 times negative 1 squared minus 3 times negative 1 minus 9. What is negative 1 cubed? Because a negative to an odd power is negative, so we'll have a negative 2 when we take that negative 1 times 2. Negative 8 times, well, what's negative 1 squared? 1. 1 times negative 8. Negative 3 times negative 1. So negative 2 and negative 8 gets us negative 10 plus 3. Positive 7, or negative 7, right? Negative 7 minus 9. Negative 16. Isn't this faster than that? Depending on the number. Okay? But in many cases, synthetic division is going to be faster than plugging it in. All right. What questions do you have about this one? Okay. All right. Factor theorem. Anybody need to stand up and stretch? Get out of their seat. Move the blood to the brain. Fidget a little bit. Get the kinks out. All right, so a polynomial f of x has a factor of x minus k if and only if f of k is equal to 0. Okay, we plug in this number and we get a 0. Okay, so we want to show that x minus 1/2 is a factor of 2x cubed minus 15x squared plus 27x minus 10. Okay, we could plug 1/2, right? If x minus 1 is a factor, 1/2 has to be the 0. So we could find f of 1/2 by plugging 1/2 in everywhere. Do you really want to cube 1/2 and then square 1/2 and then take 1/2 times 27? Most of us don't. Okay, well, unless we really love fractions. So let's synthetically divide. Again, I didn't have a problem where we have to hold a place with a 0 here. So we drop our 2. What's a half of 2? Negative 15 plus 1. What's half of negative 14? A negative 7 and a positive 27. Half of 20. Negative 10 and 10. Makes me smile. We have a 0 there. Okay. Now if we are trying to find the other factors of this big bad boy, and we know that 1/2 was 1, we've now depressed our equation, haven't we? It's no longer x cubed, which would be a pain to try to factor, right? We could factor by grouping. But now we have a 2x squared minus 14x plus 20. Because it was cubed, now it's squared. How do we factor something like that? Yeah, GCF. They all have a what in common? So x squared minus 14, not 14, but 7x. I'm going to sneeze. Plus 10. Excuse me. Okay, now how do we factor x squared minus 7x plus 10? Or can we? 5 and 2, right? And they both have to be negative. So if we set that equal to 0, 0 divided by 2 is just gone, right? So 5 and 2. But notice we don't have an x out in the front. So it's just plain old 5 and positive 5, positive 2, and then 1/2. Those are the x-intercepts, those are the zeros, those are the roots. Those are the places where it crosses through the axis. Absolutely. If you didn't take the 2 out, now you're going to have to factor it. We'll have a 2x and an x, right? If you didn't recognize that there was a 2 there. And then you've probably been told to multiply these two together, right? 2 and 20 is 40. And then say what are factors of 40 that can get me a 14, right? So 10 and 4, right? Okay, so we know we need to get a 10 and a 4. So it would be 2x minus 10 and plus 4, right? Is that correct? So, but look, if we do this, oh, minus, yes, minus, both minuses. And then what does this become? If 2x minus 10 equals 0, then the 10 comes over, 2x becomes a 10, and x will be 5. So we still get the same answer. You just have to think a little harder because you've got a leading coefficient. 5 and, hold on. This couldn't be 4 because we don't want 40, we want 20. This had to be a 2. This gave us the 4 and the 10 to get 14. And then the 10 and the 2 gives us 20. So it's still going to be the same zeros. It's just that this 2 happened to be multiplied in by one of these guys. Could have been this one or that one. Okay? Other questions you have on this slide? Feeling good about it? All right. So again, you know this. The remainder r gives a value of f of x at x equals k. If r is 0, x minus k is a factor. If r is 0, k comma 0 is an x-intercept of the graph. We saw that yesterday. Okay, we're just finding the remainder. As long as the remainder is 0, we know it's a factor. And when it's a factor, we have the zeros, the intercepts. All right, so if they ask you to verify that these guys are factors of this big bad boy. Okay, now we've got a fourth power. There is no grouping, right? So we have to do something with synthetic division. So strip off your coefficients, making sure we're not missing anybody and we don't have to add a 0 in any spot. If x minus 5 is a factor, what would be a 0 or a root? Our book calls them zeros. Positive 5. Drop the 1. Multiply, add. Multiply, add. Oops, yes. Thank you. Multiply, add. Multiply, add. Okay. Now, you don't have to go back to the original equation to verify that x plus 4 is also a factor. You can use your depressed equation. Okay? So we can just tack on to this. X plus 4 is a factor. That means what would be a 0? So we drop it down. Oops, I did something wrong. Should be a -3, not a -4. I was multiplying. You have to change your gears here. So that will be a -12, positive 12, and then a 2, and then a -8, and a 0. Okay, so we've got those zeros. That means that those two are both factors of that big polynomial. And then if they wanted us to go further, now it was a fourth power, so this is a third power. This will be a squared, right? So this would be x squared minus 3x plus 2, and we could factor from there. Okay? Thumbs up if we're feeling okay? Okay? Let's see, a lot of sideways are down. That's good. So factors, when they ask you for factors, we know x minus 5 is a factor. So is x plus 4. What would this factor into? Minus 2 minus 1. So x minus 2, x minus 1. And so the zeros are 5. Exactly. Okay, you got to be able to switch between those very easily. I think yesterday's activity probably helped with that. Okay. Assignment should be the next slide. Yep, it's on your page. Okay. We have a quiz coming up. I think, I don't remember. I think I have a review for you. But I think that will be, we're going to cover 2-4 tomorrow. 2-4 will not be on the quiz. And 2-4 is going to be a 2-day assignment. So I'll have a review sheet for you if you choose to review coming up tomorrow.